Hello friends, I hope you are enjoying my videos. Today we will discuss trigonometric ratios. So in this topic we will study the different trigonometric ratios, their formulas, and then we will discuss the resolution of force. We will resolve a vector f into its x component, y component, and we will determine the resultant of vector and as well as the direction of the vector. So please watch the video completely to understand the topic. So let's start our topic. The ratio between any two sides of a right angle triangle are given specific names. So these are the specific names. There are 6 ratios in total, out of which there are main ratios and other 3 are their reciprocals. So these are 3 main ratios, which is sine theta, cos theta and tangent theta. 3 main ratio mostly used in physics and as well as in mathematics are sine, cosine and tangent. As I told, these are the 3 main ratios. The other 3 ratios which are reciprocal, so the reciprocal of sine theta is cosec theta, and the reciprocal of cos theta is sec theta, and the reciprocal of tan theta is cot theta. So consider triangle ACB having angle theta at C. This is a right angle triangle ABC which have a theta on C, point C. So sine theta always will be equal to perpendicular upon hypotenuse. Now this is our perpendicular and this is our base, this is our hypotenuse and this is our base. So now let's try to understand how we can recognize these sides of the triangle. So please remember this. This is a right angle triangle. A right angle triangle is a triangle where 1 degree will be equal to 90 degree. So this is a 90 degree. Therefore it is called a right angle triangle. Now in the front of right angle triangle there will be hypotenuse. It will be hypotenuse, and the other side with the theta will always be base, like this. This is base. Now if the theta, if we draw the theta over here, then the base will become this side of the triangle. So please remember this. In the front of right angle, in the front of right angle there will be hypotenuse, and with hypotenuse where the theta is formed, the other side will be base, and in the front of theta there will be perpendicular. So this is your perpendicular. Now this is sine theta, which is equal to perpendicular upon hypotenuse. This is perpendicular and this is hypotenuse, and cos theta equal to base upon hypotenuse, and tan theta equal to perpendicular upon base. So this is perpendicular upon base. You can see that perpendicular is equal to AB. Look over here, it is equal to AB. Hypotenuse equal to BC. So hypotenuse equal to BC. Base equal to AC. Base equal to AC. So these are the sides. Now most of students are confusing and remembering these values, that is sine theta is either equal to perpendicular upon hypotenuse or base upon hypotenuse or what. So I have written one important sentence over here. If you remember this sentence, so it means that you will remember all these 3 ratios. But how? Let's see over here. Some people have curly black hair through proper brushing. Again, some people have curly black hair through proper brushing. Now look over here. Some means sine theta, people means perpendicular, have means hypotenuse. So sine theta equal to perpendicular upon hypotenuse. Curly black hair, So curly, cos theta, black, base, hair, hypotenuse. Curly black hair, so cos theta equal to base upon hypotenuse. Through proper brushing, so tan theta equal to perpendicular upon base. Again, tan theta equal to perpendicular upon base. So if you remember this sentence, so it means that you will remember all these three ratios. And as I told, the other three ratios are the reciprocal. So if you want to know cosec theta, which is reciprocal of sin theta, so cosec theta now as cosec theta is reciprocal, so cosec theta will be equal to hypotenuse over perpendicular. So it will so we will reciprocate it. So similarly, sec theta will be hypotenuse upon base. Hypotenuse will go over here and base over here. So similarly, cot theta will be equal to base upon perpendicular. So after getting all these things, now let's study about the this hypotenuse square equal to base square perpendicular square, which is we can write hypotenuse square is equal to base square plus perpendicular square. This is called Pythagorean theorem. So there was a Greek philosopher whose name was Pythagoras. So he gave this theorem. According to this theorem, hypotenuse square will always be equal to base square plus perpendicular square. For example, if you have base equal to 4 and perpendicular equal to 3, so square of 4 16 and square of 3 is 9, so 16 plus 9 equal to 25. So it means that your hypotenuse will equal be 5. So this is Pythagorean theorem, which is always used in solving trigonometric questions. So I hope you will have understand this concept of trigonometric ratios. Now move forward to the values with different angles. For example, these are trigonometric ratios. If you have sine 0, so the value of sine 0 degree equal to 0 and the value of cos 0 equal to 1, and similarly the value of tan 0 equal to 0. Similarly, the value of sine 30 degree is 0.5 and the value of cos 30 degree is 0.8660 and the value of tan 30 equal to 0.577 and so on. So now I will try to explain you a trick through which you can remember. So these are the ratios which I have written in fraction form. So look over here, it is very easy to remember. So the trick over here is, first you write 0, under root 0, under root 1, under root 3, under root 4 and under root 3 and under root 4. Then divide all these values by 2. So this is divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. So these are your values in fraction form: sine 0, sine 30, sine 45, sine 60 and sine 90. Now write again these values in reverse form. For example, write under root 4 divided by 2 over here, under root 3 divided by 2 over here, and under root 2 upon under root 2 over here, and this will come here and this will come here. So it means that your this line is completely reciprocal over here. This value come over here and this value come over here. So only if you remember this value, first under root 0 divided by 2, under root 1 divided by 2, under root 2 divided by 2, under root 3 divided by 2 and under root 4 divided by 2. So it means that if you remember this value, it means that you will remember all the table. So again, if we talking about tan theta, so tan theta equal to sine theta upon cos theta. So this is sine theta, this is your sine theta divided by cos theta. So 0 divided by 1 equal to 0, and this 1 upon 2 divided by under root 3 3 upon 2, so this equal to 1 upon under root 3, and this will become 1 upon under root 2 divided by 1 upon under root 2 equal to 1, and this under root 3 divided by 2 divided by 1 upon 2 equal to under root 3, and this will become infinity. Infinity means undefined. Why? Because 1 divided by 0. So 1 divided by 0 equal to infinity. Anything divided by 0 equal to infinity. So I hope it will be easy for remembering the values of all different angles in the trigonometric ratios. Now let's explain the resolution of forces, that is vector. If you want to resolve a vector into its perpendicular components, that is x component and y component. So this is a given triangle OAB, which is making a right angle over B, and which is making a theta over A. So the process of splitting of a vector into mutually perpendicular components is called resolution of vectors. So what is resolution of vectors? The process of splitting of a vector into mutually perpendicular components. So this is your vector F, this is your vector F, and you are splitting it into mutually perpendicular. What it means? It means, look over here, this is a perpendicular and this is also a perpendicular. So these are mutual perpendicular of this vector F, and you can also say that this is the projection of vector F on x-axis, and this is the projection of vector F on y-axis. So figure shows a force F represented by a line segment OA. So this is a force which is represented by OA, which makes an angle with x-axis. It's make an angle theta with x-axis. Draw a perpendicular AB on x-axis from point A. So we will draw a perpendicular over here from point A. So this is your perpendicular. The component OB equal to Fx. So OB equal to Fx and AB equal to Fy. And AB or BA is equal to Fy are perpendicular to each other. Now look over here, that is this is your Fx and this is your Fy. So these two vectors are perpendicular over each other. Therefore it is said over here into mutually perpendicular components. Into mutually perpendicular components. Here they are talking about the Fx and Fy, which are mutually perpendicular on each other. Now in triangle OAB, Fx over F equal to OB over OA. So OB equal to Fx and OA equal to F is equal to cos theta. Why cos theta? As I told, cos theta equal to base over hypotenuse. So this is your base, OB is your base, and OA is your hypotenuse. So as I told in the trigonometric ratios that cos theta will always be equal to base over hypotenuse. So this is your base, this is your base, and this is your hypotenuse. So cos theta equal to Fx over F. Now multiply this F with this cos theta. So it will become Fx equal to F cos theta. Fx equal to F cos theta. So this is called your x component of the vector F. This is called horizontal component. This is also called horizontal component or x component. Now move forward for y component. For y component in triangle OAB, in this triangle OAB, Fy upon F, that is perpendicular upon hypotenuse equal to sine theta. So Fy equal to AB, as you can see over here, and F equal to OA, as you can see over here. So equal to sine theta, as I told, sine theta equal to perpendicular upon hypotenuse. So now multiply this f with this sine theta, so it will become f sine theta, and the remaining term over here is fy. So fy equal to f sine theta. This is called vertical component. This is this is your vertical component or y component of the vector f. Now divide equation 2 by equation 1. So this is your equation 2, fy equal to f sine theta, and this is your equation 1, fx equal to f cos theta. Now this f will cancel this, so the remaining term is sine theta over cos theta. Look over here, sine theta over cos theta equal to fy over fx. As I told earlier, sine theta over cos theta equal to tan theta. So tan theta equal to fy divided by fx. Now send this tan on the other side of equation. So whenever we send our trigonometric ratio from equation from one side of equation into other side of equation, so then we can write it in inverse form. So it will become tan inverse. In other words, you can say multiply tan inverse on both sides. So if you multiply tan inverse on both sides, so tan inverse will cancel this tan, and here tan inverse will equal to fy over fx. So the both are same things. If you send this tan over here, it will become inverse. Or you can say multiply tan inverse on both sides of the equation. So if you multiply tan inverse, so tan inverse will cancel this tan theta, because tan and tan inverse are reciprocal, and here tan inverse equal to fy over fx. So this is used. Equation 3 show direction of vector f. Direction of vector f means that if you want to calculate the theta, that is what is your angle, either it is 30 degree, 45 degree, 50 degree, 65 degree or what, so you can determine the theta by this formula. If you have the value of y component, that is vertical component, and horizontal component, put the values, solve, and you will get the angle theta. So equation 3 shows direction of vector f. Now let's try to calculate the resultant vector f. So according to Pythagoras theorem or Pythagorean theorem, this is also called Pythagorean theorem, hypotenuse square equal to base square plus perpendicular square. So your base is equal to fx, so therefore fx square, and perpendicular is fy, so fy square, and hypotenuse is equal to f, so f square. So f square equal to fx square plus fy square. Now take square root, we will take square root on both sides of the equation. So we will take square root over here, and we will take square root over here. So if we take square root over here, so it will cancel this square with the square root, so it will become f, and we can write this in the form like this. So if equal to under the root fx square plus fy square. Equation 4 is used for finding resultant vector. So if you want to find the resultant vector, f is your resulting vector. If you know about the head to tail rule, so according to head to tail rule, look over here, this is your first vector and this is your second vector, which are added, and the resultant vector, when you keep the tail of the resultant vector with the tail of the first vector, and you keep the head of resultant vector with the last vector, with the head of last vector. So this is called head to tail rule as well. So if you want to determine the value of this resultant vector, which is the resultant of addition of these two vectors, so you can use the formula f equal to under the root fx square plus fy square. So this is also called your resultant vector. So there are four formulas. One is x component, second one is y component, third one is for angle theta, and the fourth one is for the resultant vector. So these all were about the resolution of a vector which was a force, for example. I hope you will have understand the topic. Moreover, if you have any kind of question or confusion in this topic, you can ask me in comment section. Thank you for watching. Please like the video and share it with your friends. Okay, take care. Bye bye.